And we are live, and this is the Science Island TWIS Minion Hangout. I'm Ed from Connecticut. Joining me is Dale from Saskatoon, is it? Saskatoon, Saskatchewan, Canada. The Great White North.
Well, it's not white yet. It's kind of brown and rainy.
Do the Mounties still ride horses there, or?
Of course they do.
They do.
It's hard for them to pull over high-speed. It's hard for them to pull over high-speed vehicles, though, with their horses. So.
And also joining me is Patrick. Joining us is Patrick from Houston. He's working on
my creator space.
recycling stuff.
Yeah, pretty much.
Saskatoon, is it? Saskatoon, Saskatchewan, Canada.
That's
The
right.
Great White North.
That's
I just
not,
have to repeat.
it's kind of brown and rainy. Is there an echo?
There was an echo.
He's figuring it out. I might be
Hello.
playing it somewhere else. Closing all my tabs.
Didn't hear anything.
All right.
Go charging on. All right.
Okay.
Two main topics tonight. The first is I've got a story about a panel-powered car that's under development. People think it could be ready in 5 years. And that's going to lead us to a topic of more efficient use of resources, maximizing energy capturing and uses, and reducing reducing waste and recycling. Then I got another really short story talking about predictions in bird populations, but the reason I added that is I want to get into a discussion of environmental changes that may favor some invasive species. Is that really a bad thing? Is it a good thing? Is it something we should try to control, or is it just something natural and we should just adapt to it? Do we really need to spend a lot of resources to keep species from becoming extinct? That sort of stuff. Got a great little story about a direct brain interface between humans. In this case, it was the same people that did something earlier last year between two people, and they've expanded that, and it was 6 people in different not in the same room, and one person thinking and another person controlling a mouse pad or something. We got a couple of stories related to what me and Dale were talking about last week, and that is being able to analyze speech patterns and then using that to monitor health over time. And we got microscopic, it says scalpels that are small enough they can swim through your eyeballs. And some other stories. Let's start with the first one. In the first one, and this is a car powered by its own body panels considered to be driving on our roads after a breakthrough in nanotechnology research by a Queensland University of Technology, which is in Australia, and Rice University. The supercapacitors, a sandwich of electrolyte between 2 all-carbon electrodes, were made into a film, were made into a thin and extremely strong film with a high power density. Film can be embedded in a car's body panels, roof, doors, bonnet, and floor, storing enough energy to turbocharge an electric car's battery in just a few minutes. And they claim that could mean a car partly powered by its own body panels could be a reality within 5 years. Vehicles need an extra energy spurt for acceleration, and this is where supercapacitors come in. They hold a limited amount of charge, but they are able to deliver it very quickly, making them the perfect complement to mass storage batteries. Supercapacitors offer a high power output in a short time, meaning a faster acceleration rate of the car and charging time of just a few minutes compared to several hours for a standard electric car batteries. Supercharged supercapacitors are presently combined with standard lithium-ion batteries to power cars with a substantial weight reduction and increase in performance. In the future, it is hoped the supercapacitor will be developed to store more energy than a lithium-ion battery, while retaining the ability to release its energy up to 10 times faster, meaning the car can be entirely powered by superconductors in its body panels. After one full charge, this car should be able to run 500 kilometers, similar to a petroleum-powered car, and more than double the current limit of an electric car. And Dr. Liu said the technology could also potentially be used for rapid charges of other battery-powered devices. I'll stop there. How's that sound, guys?
Oh boy. We've been hearing about supercapacitors for so long. This looks like it might be selfless promotion. Maybe they've made some interesting breakthroughs, but extraordinary claims, right? Extraordinary claims require, what did Sagan say?
Within 5 years.
Within 5, so this is going to be like the hydrogen cars in the 80s. Within 5 years, we'll all be driving hydrogen cars. I don't know. I don't believe it. I think capacitors, supercapacitors, I don't know. I don't.
Supercapacitors don't actually have the same amount of capacity as an actual battery pack. Their capacitors are meant for quick charge-discharge cycles. So you get lower mileage per pack or per charge, but you'd be able to charge them really quickly. So that's the flip side.
So does that sound like then this could be used for to complement the electric batteries and electric cars? So it would only help.
You could use it as like a it would be like a supercharged engine. Like you could have a bank of capacitors in your car. You could hit like the turbo button, and that'd give you an instant oomph of speed or whatnot. I have a friend here that is making an electric motorcycle that is going to be a hybrid capacitor battery bank. So when he needs an extra oomph of speed, he can just flip to the capacitor bank, get that extra supercharge out of it, and speed along. That's
what about, they're talking about, so they're hooking up panel. Now, if they're putting the panels on the top of the car and on the panels of the car, is that going to be using solar power?
I wasn't quite sure what it meant by the body panels for power generation. What? Is it using those as capacitors? Because that seems dangerous to me, because in a collision, that's going to be an issue.
I never saw a picture of it, so I don't know.
Yeah, there's no picture.
They're talking about making the car into one gigantic capacitor. I think
that what you're talking about?
Okay, if I'm a firefighter and I show up to a scene of an accident with one of these supercapacitor cars, I'm sorry, but the occupants of the car, I'm not going to get to them, because that will discharge quickly, and these things require high voltage, so that would be very interesting. I don't think safety groups are
there could be some method, like, you know, the jaws of life are very specialized. This is just big frickin' hydraulic cutters, right?
Electric bolts on everything.
Yeah, you could do it. Oh yeah, you could do electric explosive bolts.
Explosive bolts charge when it discharges. It charges through the bolt, the explosive bolts.
I was gonna go with they could shoot some sort of like grounding, like crossbow thing at it, so it grounds the whole car, and then that discharges into ground, so that way it's safe.
Electrocuting everybody who's in the area.
Yeah.
No, that's not what would happen. It takes the path of least resistance.
Yeah. Yeah,
This is
human
what we
body.
do here. We make this kind of stuff when we have.
We're
the
doing
tools.
away with the surplus population.
Well, we do have a surplus population, so.
What's the resistance of the ground? It's going to
Um,
be a lot.
yeah. Oh, okay. Yeah, well. Anyways.
Yeah, that sounds like, to me, I just the way the guy's smiling, he kind of looks, no comment. I'm sorry.
Purely on the Professor Nunzio Mata
Right.
with one of the university's powerful.
I didn't see a link to a Kickstarter or anything, so.
No, this is pure research.
I think they're fishing for money here. Like, he did get published in the Journal of Power Sources. I've never heard of that one. And nanotechnology. I don't know.
Technology.
Right. It's what get published for. I think you get published for something, but now they're kind of baiting the public through a news story to get funding, I bet.
What about the idea of putting solar panels, incorporating solar panels in the panels of the car itself, the roof, the hood?
That's nothing new. They've been doing that in solar races for decades.
What keeps that from being used and put on Elon Musk's car and future electric power cars?
Well, they just don't generate all that much power.
In supercaps, you need high voltage.
Yeah, if you need supercaps, you want high voltage, and you're not going to get a high voltage out of a solar array. And it's more of a trickle charge, if anything. The only reason that they have them on the solar car racers is whatever, is because they need to park it and they can't charge it. And as long as their sun's up, you might as well get as little electricity as you can, but that's just to eke out like an extra couple miles, maybe an extra 30 miles or so. So picture a 1 kilowatt solar cell. Those are like about a square meter or so. And the battery pack on a Tesla is what, 200, like it's like 80. No, it's like 85 kilowatt hours or something like that. And that only gets you 250 miles or something like this.
Yeah.
And so if the surface area of your car is only, probably maybe 10 square meters total of space with like the door panel, the hood, and the backside and whatnot, then you're only getting 10 kilowatt hours, or 10 kilowatts. And your pack is 85 kilowatts, so that's only going to give you an extra 30 miles, maybe.
So that's almost like a spare tire. You know, if something happens and you need a quick charge to get you to the power station or whatever, maybe you can use
if you had like just a strip of solar cells or something, and you were in the middle of the desert, yeah, sure, you could probably get. I mean, that's like high efficiency right there. You've got plenty of sun, direct sun, no clouds. You could trickle charge your pack that way, but it's still going to be slow going. What you really want is the fusion engine.
Oh no.
fusion engine.
Okay, so we're going from basically taking the human being that's in one of these capacitive cars, and we're talking about such high voltages that we're going to turn the human dielectric into a conductive path to ground, right? Now we're going to go to fusion generation, and we're going to wipe out blocks. Is that...
Fusion?
Is that everything?
No, you're thinking fission. I'm talking fusion.
Oh, fusion, not fission?
Yeah, fission is the explosive thing. Fusion is the...
It makes a sun in your car.
Yeah, it makes a sun in your car. But a very, very small one.
How much progress are we
I'm
making?
never clear on how you generate power from fusion. Is it from thermal energy, or is it from photovoltaics, or both? Or is it from steam conversion? Because that seems silly. Like the only actual generator we have is...
I think it's all heat, which would be
thermal, so it'd be a steam. Yeah, that's silly. But
So
that's all we got.
engine.
What was that?
Or
Yeah,
going back-
it'd be a fusion-powered steam engine is what it would be.
We're going right back to the start of the automobile.
Yep.
But okay, you're talking fusion, right? So atomic nuclei colliding.
You get a little bit of radiation, but not much.
Plus the plasma, right?
Not nearly as much as yeah.
No, because it's
No,
not.
You got to have a lot of protection on that plasma, so nothing leaks
Right.
out.
Plasma is not.
Yeah. Anyway.
Plasma is a fourth state of matter. That's not. Anyways, so. I don't know. Anyways. I digress.
That's fine. That's all we're going to do tonight is digress.
You're not in the same. You're not in the same facility as NASA facility as AJ, are you? You're in different facilities.
AJ is not.
Where are you?
Did AJ say he was working at NASA?
Yeah.
Yeah.
Johnson, I thought.
Yeah, that fell through.
Oh.
Oh.
Yeah. No, he would have been working in my office.
Okay.
It's okay.
Okay.
But-
You know, Patrick, have you heard? I mean, we've been hearing about fusion generators. About once a week, I see a post somewhere talking about somebody who trying to build a model. Is there a working thermal reactor anywhere? I know the French have been trying to do it for years.
There's a few of them. There's the National Ignition Facility. There's the Topomac. There's a new one I recently heard. Oh, the Lockheed Skunk Works? Yeah, Lockheed has a compact fusion reactor that they've been working on.
But
They
there's
say
not
they're
one
really
functional.
close, but everybody always says they're really close, so it's like... They opened up theirs because they have a new way of making them smaller, so they can get more people trying to vet their process, I guess. So there's at least 3. None of them are working like sustainable, but they've gotten like microbursts of energy out of them.
Yeah,
I
they've
think-
created more than they've used, right? Like the National
Right.
Ignition Facility,
Yeah.
192 lasers aimed at a single tiny tritium target.
It uses like the combined power output of the United States in one like nanosecond or something. It's got giant capacitors on it, so it's like, yeah, it's like 4 or 5 football fields of mirrors bouncing the thing around to a very infinitesimal point. It's pretty sweet. Just giant frickin' lasers is all you got to know about it.
Okay. Well, the French seem to be the only one who put a bunch of money into trying to build one, and we can see how well that's worked out for them. So.
No, they're not the only ones. NIST is done by the Department of Energy, which Department of Energy, all their job really is to keep the nuclear bombs intact. So they don't really spend all that much time on it. But Lockheed, it's in their best interest to get one working because that'd be huge for them because they're a private company. So.
I mean, if we can, we need to do something. We need to either build nuclear reactors, or I mean, a couple of people have suggested we need to build fusion reactors, but we don't have a working model. We don't have a full-scale fusion reactor yet, so we need to build more nuclear reactors and start building them as quickly as possible.
Yeah, you know what, Ed? I think in the southern latitudes around the equator, I think solar is very quickly going to take over as the dominant force. I know it doesn't seem like it at the moment, but if you look at some of the data plots that are out there, starting in close to the equator and building from there as efficiency gains and cost reductions keep going, I think decentralized power. That's kind of what Tesla is doing, right? Or Elon Musk. So he has his electric car company, which has succeeded. He has SpaceX, which he wants to colonize Mars. He smiled about that. And
also
then
has Solar City.
and he has his business with solar panels, where he's basically putting them on roofs all over America. And I think he's going to end up with one of the largest power plants in the U.S. at one point.
Yeah, by 2016, it'll have the biggest combined solar output of the country, I think.
Yeah, up front it looks like a silly business plan, but looking long term, it's actually may work in his favor. I think he's a pretty savvy guy.
Solar panel,
just on the board of directors.
solar energy uses, I think, is doubling each year now in the United States, maybe more. So I would say that's a good model, because is it 10–15% of energy in the United States now is solar?
I don't think it's that high. That sounds
Okay.
really high.
Let's see.
That'd be awesome if it was that high, but I don't think it is.
Solar energy in U.S. let's go with 13. Let's see. Well, this solar energy, it says it's grew by 41%.
Solar energy provides 0.3% of the total energy consumed in the United States. While the amount of solar electricity capacity in the U.S. has increased in recent years, it still only accounts for 0.2% of net utility-scale electricity generated in the United States. That's from the Institute of Energy Research.org.
That's different from what I'm looking at.
Gigawatts of installed photovoltaic capacity, with an additional 5.5 gigawatts of concentrated solar power.
What were we talking about? Sorry, I had a very important thing to do. Autumn's DVD had to be put in, so. Oh, my leg again. Got to keep that down.
Utility scale power generated 15.78 million megawatt hours, 3.8% of total U.S. electricity capacity. It doesn't say anything about residential consumption.
Screen share I was looking at. This is the Solar Energy Industrial Association. That says new. Okay, that's just new. U.S. Okay. Well, I would say that, 2013 it went from 10% to 29%.
Of what?
Of
new. Yeah. Brand new stuff, it's 29%. But combined use, it's still only 0.38.
So even with the new energy uses, etc., natural gas is still way up.
That surprises me. I would think we'd be putting out more and more power plants, but it doesn't seem like we're going at that big a clip.
It's not power plants, it's individuals.
Well, it's power generating capabilities.
If they're off grid, they might not get reported by that.
Yeah, if they're off grid, they might not be reported. But I would check out Solar City's stats.
It seems to be growing, and
exponentially.
Got to get that battery so you can save your energy and use it at night. Use it at any time. We need that better battery for storing solar energy.
It doesn't have to be a battery specifically, or an electric battery specifically. It could be a heat battery. That would not be photovoltaics, though. That would be solar thermal. Fancy.
Patrick, let's just get together and we'll meet at Ed's place and we'll invent something and sell it.
It's so easier said than done.
I think we can do it.
Every material has its own drawbacks. There's no perfect. There's no unobtainium. It's just unobtainable.
Yeah, solar energy. I mean, there are states that are putting money into solar energy, more and more states every year. But it's my perception, it's really mostly driven by individuals. You have that company where you can rent them, and they take care of the maintenance.
Yep. Solar City owns the panels. You're just renting them at a flat rate so that your electricity bill really never changes and it's predictable.
Yeah.
They've made it cheap.
Yeah. On the energy resource front, efficient use of energy, I would say your government's lots of talk, no action, or very little action.
4%. Wow, that's really good.
Annual yield.
Yeah.
Yeah, all right. Ready to go on to the next topic. Or we can jump back to the other one at any time you want.
No, we can go on.
This is a very short story. It's talking about bird species. Distribution of bird species in the U.S. today will probably look very different in 60 years as a result of climate, land use, and land cover changes. Now, of course, big duh. And they made predictions where 50 bird species will breed and live in the continental United States by 2075. Some species will, like the bird sparrow, and there will be significantly more of these types of birds. Their range will nearly double. Habitat loss is a strong predicator of bird extinction at local and the regional level. Climate change will cause average temperatures to change by 3 to 7 degrees Fahrenheit by 2075. That's pretty significant. 75, that's 60 years. That could happen, depending on different scenarios. Okay. Temperature increases will drive breeding ranges for many species to the north. Precipitation will increase in some areas and decline in others. Habitats for birds currently breeding in the far south U.S., such as the desert-dwelling Gambel's quail, will expand greatly by 2075 in the continental United States. Landscape changes resulting largely from human activity, including land use and land cover charges, will also significantly affect future bird distribution. I'll have this in the show notes, and they've got a bunch of different species, some that will gain and some that will lose. The main reason I wanted to include that story was to lead into talking about
That's a flyer.
really
Life.
the environment changes, new species come in and help some, doesn't help others. Okay, so now we got these what are called invasive species in many areas. And a lot of people say that's a very bad thing. We got to control and get rid of these invasive species, plants and animals. But really, isn't this evolution in action? Do we really need to take a lot of action?
I think that's really funny. Like they call them invasive species, and you got anything that finds a way in this world to survive and thrive, and it's amazing. It's gone through this evolutionary process where, whether it's a weed or whatever species it might be, we tend to want to exterminate it for some reason. So it's kind of...
I think you guys might have the wrong impression of what an invasive species is.
Okay, what is it?
It is typically a species that is completely and utterly out of place from where it should be.
And it's our fault.
Yeah, and it's our fault that it was there in the first place. It was brought there by us through cargo, or mostly cargo, or farming or something like this.
Yeah, what is
Where it completely disrupts the habitat of that area and screws it all up. It's not like the zebrafish, which are slowly invading estuaries and stuff like that. I mean, they say that that is kind of considered an invasive species, but it's not. That's just more of a species migration.
It's like wild boar in Texas.
Yeah.
And they eat up all of the wild boar in Texas eat up all of the like they'll eat up farmland. They root around and destroy a lot of things. And part of the reason we don't like it is because we can't control it, so we have an issue with it.
Yeah.
But I mean, generally the term invasive species is more derogatory because it is harmful to the whole ecosystem as a whole, rather than saying it's invasive because it found a way to survive in that environment.
Right. It's like was it rats that were brought to Australia?
Potentially, yeah.
Yeah, rats or mice that were brought to Australia and are not native to that continent, completely destroyed all of the farm harvests and whatnot. And so they released, I think they released snakes or something, and then there was this whole chain of events that took place. Like that Simpson episode. That Simpson episode.
Cane toad.
Yeah. The Simpson episode where the horny lizard or whatever cracked out of an egg from Bart's nest or something, and then got everywhere, and then they released the snakes, and those got everywhere, and then they released gorillas. Apparently killed the snakes, and then they would just let the winter kill off the gorillas.
Yeah, that's Australia. That would be a classic example of what I was thinking of, where they try to intercede because they say there's a species that's coming in and wiping out the poor native species, and the only thing they do is compound the problem. They exchange one kind of vermin for another.
Well, here's an incident where they succeeded. So in my hometown of Omaha, there's a man-made lake. It's Zerinsky Lake. It was an Army of Engineers lake or whatever. It's mostly just a runoff area to control water flow and whatnot. But there was a Boy Scout or something that was walking around the lake and noticed this clam or this mussel, and it turned out it was a zebra mussel, which is an invasive species. So what did they do? They drained the entire lake for a year so that it would kill off all of the mussels. And then they refilled it up and stocked it back up. And so I believe that would be a successful instance.
That's interesting.
They had to drain an entire lake, a really big lake. But, yeah.
That's the Great Lakes, right? The zebra mussels got into the Great Lakes.
I think so, maybe.
Clogged up. They've been clinging to ships and stuff. Real problem in the Great Lakes, zebra mussels.
Right. But it's not just that species are migrating by themselves and are causing us issues that is an invasive species. Those are just new migrational patterns. Invasive species are the ones that are completely destroying the environment because it was our fault. That's an invasive species.
Yeah, it's the destruction of the environment. Like the is it the South American anaconda or that snake that got into Florida?
Yeah.
It's now in the Everglades and it's killing all the native species, the alligators.
Mm-hmm.
So human beings are an invasive species.
Yes, that is true.
Yeah. Because that would be that's an example.
I think back to what is that computer? The Matrix. We are a virus. They're just infecting everything.
Or batteries.
Yeah.
Yeah, but think about all the little bacteria inside us that we bring along with us. And everything, we just change the environment. And that helps some critters and other critters not so much. Our homes. We got all kinds of critters in our homes now that love us. Thank you so much for building us a shelter for the winter. As an example, in Florida, should we be doing anything at all? Should we be worried about the fact that we've got these snakes, these anacondas, if that's what they are, that are reducing the population of alligators?
Yes.
Because we don't understand the repercussions of having them there, and they can destroy an entire ecosystem.
Right. Destroying ecosystems is not something you want to mess around with.
That's our job. We destroy our ecosystems.
Exactly.
Let's leave that to the human.
That's Ed's point exactly.
Oh my God! Look what we're gonna do to Mars.
That doesn't really have an ecosystem that we know of, so yeah. Well, that's true. Although I've been trying to figure out the best way to release an atmosphere on a planet-sized object.
Hit it with a comet.
Well,
Hit it with lots of comets.
Yeah, there's that, but I keep wondering, like, if I open, like, an air tank or something, just an air tank on the moon, which has no atmosphere to speak of that we know of, is it that flying out straight into space, or is it actually hanging around in the moon's gravitational pull, creating a uber micro atmosphere, so to speak?
It gets hit. There's no atmosphere to protect it from cosmic rays, so it gets hit by cosmic energy.
And then
it has higher energy and just dissipates.
Okay, all right.
The gravity alone is not enough to hold it.
But you would need to do it a lot so that it would still. So that's the Van Allen belts that are deflecting our cosmic rays.
To some extent, not like an atmosphere does.
Well, yeah,
Like
but when
does.
the cosmic rays hit the atmosphere, that'll bounce them to something else, right?
Right.
So it'll be destroying our atmosphere. So either way, our atmosphere is going away because the cosmic rays are stripping it off.
It's been too long since I've taken a meteorology class to remember.
Is meteorology?
Yeah.
All right.
That's how all planets get seeded. Asteroids and comets.
Yeah.
Even the water we have, doesn't that come really from comets and asteroids hitting us?
Yeah, but my question is, how did the comets get it?
That was God intervened and made water on comets. So.
Wait, what was that part? I missed that.
God intervened and put water on.
Hey, Dale, what's with your little moniker below your name?
Oh, that's just, you guys got to figure it out.
Autumn. Let me guess. Autumn.
Oh, there's so many A's in my life. It's wonderful.
It says I love A below his name.
Is it because he's Canadian?
Oh, is it because you're Canadian?
Oh, very good. There's A jokes left and right. Do I say A a lot?
Not really, not that I've noticed.
I don't notice. I know some Canadians who I can immediately tell they're from Canada when they speak, but that's not the case with you.
Only when you said sorry.
Yeah, you can tell by the way they say sorry.
I'm sorry.
Yeah, like that.
Plus the A. I had my cousin who lived there.
Boy.
I guess we're just all crazy up here. Crazy, 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 crazy.
No, they're more sane.
I don't know, they have some fricked up laws and stuff.
You know what, Dale? When we need water, us Americans are going to become an invasive species in Canada. We're going to infiltrate Canada.
I don't see it as an invasive species. We're going to have a big party up here.
There you go. It's going to be beer.
Yeah, back bacon and beer.
I'm not looking forward to the day when we have to go to Canada to get water, because that'll be the day that the permafrost is thawing out and will really fuck stuff up.
You think so? I don't know. Permafrost, global warming.
Permafrost, methane. It doesn't hang around as long, but it's way more potent than CO2.
Yeah, it's
Which
not,
means it'll just get hotter and melt all the rest of the permafrost out there, and then it'll really get hot.
Yeah, but Canada's already got tons of water and lakes.
Whenever Patrick's on, I can't live in my world of denial because he says it like it is, and it's very disconcerting.
Isn't it, though? Isn't it? I'm a very blunt person. I used to lie, and now I just tell it as it is.
You're a scientist.
All right, let me jump very quickly into another fascinating story, a direct brain interface between humans.
Oh my goodness.
Screen share it. There's a picture. That doesn't look too invasive, does it? University of Washington researchers have successfully replicated a direct brain-to-brain connection between pairs of people as part of a scientific study following the team's initial demonstration a year ago. Newly published study involved 6 people. Researchers were able to transmit the signals from one person's brain over the internet and use these signals to control the hand motions of another person within a split second of sending the signal. The new study brings our brain-to-brain interfacing paradigm, that's the word, from an initial demonstration to something that is closer to deliverable technology. Now we have replicated our methods and know how to work reliably with walk-in participants. The researchers combined 2 kinds of non-invasive instruments and fine-tuned software. Does that look like non-invasive instruments there? I don't know. And fine-tuned software.
Not internal, so therefore it's not invasive.
Well, the guy on the left, not too bad, he's wearing a helmet. The guy on the right, though, I don't know. I don't think I'd want to be that guy. I'm not going to participate in that. Let's see, the process is fairly straightforward. One participant is hooked to a electroencephalograph, whatever, machine that reads brain activity and sends electric pulses via the web to the second participant, who is wearing a swim cap with transcranial magnetic stimulation coil placed under the part of the brain that controls hand movements. Now, that's all over the internet, so I'm immediately thinking somebody's going to hack into that. Using this setup. Go ahead.
It's interesting. It's really interesting. But it's great that they can do that, like have that kind of control, you know, via an EEG. And then they're using that donut-shaped coil of wire to directly stimulate certain portions of the brain. That's cool, but I just what's the application, I guess? Is it, can you somehow link it in?
I can tell you one right now.
What is it?
So imagine there's an emergency, right? But the trained professionals aren't there. But you have people willing to go into the emergency situation, and the trained professional is available, but he's 1,000 miles away or something. And so you have the trained professional wear the transference cap, right? And then you have the volunteer have the other cap, and they can take control and do the professional thing that only they have the skills to do in that situation using the other person.
Gail, that's Patrick, rather. That is exactly why they did this. That's exactly the application they were talking about.
Yep.
Now, they talked about teaching. A brilliant scientist in one area and somebody else who's learning about science. And I'm not sure how that would work in terms of controlling hand movements. But if you can just send information, and you get down to each little skull cap or something on, and there's the interface.
Alright, now I'm in the shop.
There you go.
There you go.
Does this mean that therapy sessions aren't going to be like, tell me how you feel? Now they're going to be like, oh, okay, now I got it. I know how you feel now.
I don't know if it's feeling transference, though. Is it? It's not feeling transference. It's motor control.
Oh, is that?
Yeah, well, for the moment it is, anyways. Memory, emotional transference. That's more of a chemical interaction than a neurons firing thing. I mean, I suppose you could fire the neurons to trigger a emotional memory or something, and that might work.
Emotional. I could see where, let's say, you two guys are in different parts of the country, and one of you is trying to build that motor. The other person knows how to do it. One person knows how to do it. The other person has only got the material. The person who knows how to do it could send the signal to the person with the material, and help them build it.
Yeah, or you could, the other person could just tell them how to do it. But that's not necessarily a specific skill set that you need. Like, most people can connect one wire to another. It's like if someone is about to die from something and you need like a skilled surgeon, even then, I don't know if you...
Somebody's having a heart attack on the road.
Yeah, I was
and
gonna
there's,
say, like,
you know, standers by.
It's gonna be.
I
Sorry.
think we had each other. That's all right. Yeah, we were wondering if, like, the professional surgeon, right? He has very trained muscles already in his extremities. If you were to control someone else, is that more of a mental component to controlling your muscles, or is that really honed fibers in the muscles themselves that are able to do that? Like if you're someone with Parkinson's, can you transfer your shaky muscle syndrome to somebody else who doesn't have it, or vice versa? Can a surgeon control that person and take away the shakiness? That would be an interesting experiment.
Brain to brain or brain to muscle?
Brain to brain, but is it the brain that controls the shaky muscle, or is it the muscle itself that's having the problem?
Well, I got a Parkinson story later in here somewhere, but I think it's brain, I would guess.
Well, because
something to do with the neurons in the brain.
Michael J. Fox has Parkinson's.
But I've got another story that'll help explain that later a little bit better.
You're talking about the essential tremor.
Yeah. There you go.
Yeah,
Well, one problem when you go to a doctor and the doctor says, does it hurt? And you say, yes, it hurts. And how much does it hurt? Well, I don't know. I could say it hurts really bad, and you think it's nothing. So if you could hook up some kind of a machine so the doctor can feel the amount of pain that you are feeling, it could give them a better idea. It might be able to, you're talking about psychology. How depressed are you? Well, if the therapist could hook up to your brain, the therapist might be able to gauge better just how depressed you are.
Yeah, but I still think that's more of a chemical reaction than a neuron.
A lack of serotonin rather than.
Yeah.
The lack of neurochemicals rather than like a neural response or like a.
It may be a combination thereof.
Yeah.
It may be the chemicals that cause the neurons to fire, and that's probably actually how it works.
Mm-hmm.
It's
well,
the chemical.
Exactly
Yeah, it's a neural. How do I say it? It's an electrical chemical. It's an electrical chemical reaction that's causing the issue in the first place. So, so maybe you would be able to transfer emotions
to some degree.
Yeah. So if the patient has very depressed and they transfer the synaptic responses over to the doctor, then that should cause the doctor to feel a momentary depression or anxiety without the chemical release, or perhaps it would cause a chemical release, which would be really interesting. If it doesn't cause,
it would cause a chemical release.
Yeah, but if it doesn't,
no, but it'd be back.
If it doesn't, though, the doctor would still have that reserve of the chemical. Like, when you have serotonin, but you only have so much of serotonin.
It's like when you take too much ecstasy, and it makes
it so you can't have it. Right, exactly. So you can't have it for.
When we take too much ecstasy, excuse me, where are you guys working? You got a lab back there somewhere?
No.
Past experiences.
I knew a guy. No.
Actually, I knew a guy. I never did. I was the driver.
No, we're just talking about the interrelatedness of like synaptic response to chemical response. And so I guess a good gauge of that, or a good analog to that, would be drug response. where you have a chemical interaction that causes a neural state or causes a synaptic response. So we were trying to kind of get to the bottom of whether in a transference of emotion, if you're sending the synaptic state, does that like grandfather in the chemical?
Right. If you're sending the fingerprints of the brain from the patient to the doctor, does that print that's imparted on the doctor's brain cause the chemical reaction to happen, or does it just trigger like the memory state of said chemical reaction?
Right. Is it purely electronic neurons firing, or is it
I really want to do this experiment.
we got to get PhDs, dude.
I know people. It's all about networking. I like that.
Yeah. Speaking of networks of neurons. And
Right. Anyways, do you guys have any info?
see, but there's like the wire.
Dale's a bio guy. What's he have to say?
I think you're talking about, so you're talking about emotions, right? Can you somehow transfer emotions? And so there's a process called exocytosis, where it's the process basically of the neurotransmitters are binding to the receptors.
Right.
And that's the synaptic function part of it. So can that process, and then after that, there's your a graded electrical response modulated by that function. And depending on how it's modulated across trillions of neurotransmitters, that pattern will cause an effect. So that's the mechanical part of it. The emotional part, I don't think it's completely understood. Like, I've seen a lot of different really great papers on all sorts of specifics. I don't think we have all the knowledge put together yet on precisely how it works. And I think that's kind of the challenge with AI. They're trying to, they're working on different layers of abstraction within silicon in order to create an AI. And they're taking guesses at it because we don't understand human anatomy enough. When you get into Parkinson's and essential tremor, I know those are two different functions. Essential tremor is when you're going to move your muscle, you're focusing on moving your arm, for instance. And when that happens, you get a repetitive tremor when you actively think about it, where Parkinson's is completely passive. You're not thinking about it and you're shaking already. And quite often doctors misdiagnose the two of those things because they are different types of brain chemistry. So in a long kind of drawn out way, I think basically we have a whole bunch of information, and I bet there's enough out there that if we had the almost like an epidemiological approach to it, that we could put all those puzzle pieces together. I bet you we could get pretty close, but it's almost like we need the AI portion of things to take all these millions of clinical studies to make sense of this complexity, if you know what I mean.
You need what was Kevin calling it, a mind node or neuro node, I forget. There's a type of computer programming neural net, yeah, there you go. You need a neural net to figure it out.
Yeah, and as that comes online, I think very quickly all of human knowledge, like Watson.
Yeah.
I'm not sure if that's a type of neural net, but it's very similar. And as that comes online and is able to discern all this knowledge you've accumulated, big data essentially, right? Hopefully we'll get close. But I bet you they will figure out something that you can change the chemistry of the brain via electrical stimulation. It'll be how much can you change it? Can you change it in a certain way that to create the correct pattern of neurological activity to create emotion? That would be interesting to see how much you can modulate it.
Brain stamps.
Don't
I'll be
when
the
they do-
way
when they do brain surgery, don't they hook the different electrodes to different parts of your brain and then press a button and see what happens?
They do that in rats. I don't think they do that in people. Or they do it in
Not
chimps.
ethical.
Yeah, it's not an ethical thing to do. But when they're doing actual brain surgery, the patient is awake, so that when they do hit something in the brain, they can say, "Do you feel any like tingling sensation anywhere?" or such and such like that. So, yeah, brain surgery, patient's never knocked out unless they're like in a coma or something and they're like removing a tumor or something like that. But even then, they want the person to be lucid so that, because there's no pain receptors in the brain, in your cranium. It's yeah, your scalp and whatnot. But once you get past the bone, your skull, there's no pain. So you can have that whole thing open. I have to think like it might feel like airy or something. But yeah, so they want to make sure they're not cutting into something that's going to like cause severe motor control. But for the most part, we know what not to touch. Although we're still doing stuff to figure it out.
The very next story, talking about being able to evaluate changes in depression by listening to how somebody speaks. Let's see, the University of Maryland researchers, 6 patients over a 6-week course, registered as depressed some weeks and not depressed other weeks. They compared these patients' Hamilton scores, whatever they are, with their speech patterns each week and found a correlation between depression and certain acoustic properties. When patients' feelings of depression were worse, their speech tended to be breathier and slower. The team also found increases in jitter and shimmer, 2 measures of acoustical disturbance that measured the frequency and amplitude variation of the sound, respectively. Speech high in jitter and shimmer tends to sound hoarse and rough. And they plan to repeat the study. I don't think they go into any other detail beside that.
That sounds more like a study where people knew this happened anyways, but there was no data on it, so they had to do the study. It's like we know killing people, or we know that falling out of an airplane without a parachute will kill you, but no one ever did the study, so we don't know for sure.
Huh? I thought they were talking about just recording how people are speaking and noticing changes, and then being able to evaluate those changes and say, okay, a certain type of change means more or less depression.
Figure it out.
Well, I know there's a blood test that that'll be out in a couple of years, and they're measuring at the epigenetic level. Like there's 9 different types of RNA strands that they're looking at within your blood markers, and that will be really interesting. I don't think it'll be the whole story, but I think they'll be able to actually grade your depression from a blood test very, very soon. And
wait, they're going to create depression in a blood test?
They'll be able to grade it.
Oh, grade it. Okay.
Yeah, so they'll be able to see how depressed you are and what state you're in. And when you have that knowledge, you can actually begin to target better drugs for a specific person. So it moves down that whole line of...
That's interesting. So now we're looking at... First there's genetics. We thought genetics controlled everything. And then we found out that RNA controls a lot of stuff. And then we found out bacteria controls a lot of stuff. What else are we using that controls a lot of stuff?
Yeah, no, that's a good point. Well, I think within each of those, like you talked about the microbiome and all those different things, even within the microbiome, right? So there's thousands of species of, hundreds of thousands of species of bacteria all over your body. Like it's 10 to 1 or 100 to 1 compared to your own cells. We're outnumbered by bacteria. So and each of them have different code within them that all do different things. And they're all doing different things millions of times over. And how do they come together? Like how does it within the microbiome, each different specific bacteria type interact with each other? And then when they interact with each other, it's almost like, getting into a weather scenario where you're trying to predict the weather with a chaos theory and a butterfly flaps his wings, the whole.
Okay, so this probably has no factual basis whatsoever, but I'm just putting this out there. What if there's a emotional state or an effect on humans, mammals, life forms via solar cycles? Like the amount of radiation that a star is putting out.
Could well be possible.
Like maybe we're at peace for a while, and then we start breaking out into war, and everybody's angry for a while, and it's just based on the solar cycles or
There's
cosmological something.
There very well is a non-enumerable infinity of things we interact with on a daily level that we just can't predict to that degree of certainty.
Medicine will be statistical. It'll be based on probability.
Yeah.
And as we get better at it, it'll get closer to quantum states.
Which is why you need more than one doctor to give you a diagnosis.
Yeah, doctors will be.
Likelihood of wrong is high.
I think Watson is the future. You'll have more of a statistician and interpreter of the data that works with your AI is the future. Because doctors can't do it. Like some of them took medical school 30 years ago. And yeah, they have more knowledge and practical experience than the person that's walking in. But imagine if every person on their smartphone, could have their DNA sequenced by their spit on their smartphone, and the database interprets what health state you are. I mean, I think that'll be the long-term goal.
I think actually like WebMD with it'll give you like a quiz of stuff, and it'll go through and it'll say, oh, it could be this list, and then you can refine it even further and further and further, and then that'll probably be.
To what degree does your interaction with that list?
Yeah.
Will it take the data? Will it
right.
take the data from you giving it a list and analyze that as well? Like the fact that you're thinking about this list might apply to you.
Right.
We'll add back into that list. It'll be recursive.
That's how they do HR tests. Like when you're applying for a job, they give you the questions like 3 or 4 times to see if you change your answers any.
Well, what he's kind of describing there is almost like white coat syndrome. By the process of going to the doctor and you see his white coat changes your health state.
Yeah.
Just like taking this test. If you begin to panic and worry about it because of your answers or whatever the case may be, it feeds back into your health system, and it becomes cyclic.
Like if you, I don't know if you've ever spent much time on WebMD, but if you,
good way to become a
It is. Like you can, like the last option of a problem on something is usually always ends up in cancer. Like, it could be this, it could be this, it could be this, it could be this, it could be this. If it hasn't healed over this amount of time, go see your doctor, it could be cancer.
Yeah, for sure. And cancer really is just, depending on what layer you're looking at, it's usually mutations of some sort.
Right.
Okay, you were talking about the microbiome? Biome. Okay. So now you don't only have to treat yourself, you have to treat your microbiome.
Right.
So that could be depressed. And not just you being depressed, it could be your microbiome is depressed. You've got to treat both.
Definitely. I mean, that's like sugar or whatever, where if you have too much sugar, your microbiome gets unbalanced and it causes all this cascading effects down the line. Your nutrition suffers, et cetera, et cetera. And, I mean, nutrition is if you don't have the proper nutrition, you're not going to have the proper chemical balance in your body to begin with, and that could cause depression.
And we have to be so careful because people, they buy into, they sell probiotic pills.
Yeah. Currently have actual no basis with scientific research right now. I mean, it's there. You know stuff happens, but the stuff that they're marketing has nothing to do with anything.
Well, just think about it for a moment, practically. So, say you have 100,000 strains, and I'm just throwing it out there, of bacteria. if you think you're going to cure yourself by throwing 5 into your body, not that great. Here's the other part: is whenever you ingest something orally, if it's a pill, it has to survive the acids in your stomach. It's a very harsh environment. And to get a probiotic, an active ingredient, into your system is exceedingly difficult.
Mm-hmm.
That's the challenge, right? They've tried gel caps and things that can make them survive that process, but they haven't had a lot of luck at really.
There was a recent one that was on TWIS like 2-3 weeks ago, maybe. Basically, they take stool samples of a donor individual, they encapsulate them, they freeze them, and then they give them to patients. And
Yeah,
I'm not sure if the capsule itself is resistant to the hydrochloric acid or something, and then it falls in the small intestine, or
You're
what.
eating common shit.
It's got a high success rate. It's got a 90% success rate so far.
Yeah, and you're eating a healthy person's shit, basically, is what it comes down to.
Well,
That's precisely what they're doing.
yeah,
And
exactly.
it does work. That's the
Right.
crazy thing. It does
I know.
work.
So even if it's not the capsule and it's just like whatever happens to be surrounding the bacteria at the time, it still works. Frankly, shit is just dirt
Yeah.
with
Yeah.
lots of bacteria in it. And if you call dirt, what is dirt with lots of bacteria? Soil.
I wish we could re-educate the public into what these words mean. Because when I think about bacteria, I think of a massive, complex, computationally based assembly linkage or plant that does all sorts of massive.
We have a new audience, Dale. Watch your language.
Yeah. Oh, hi. Want to sit here?
Yeah.
We're talking about eating poop. All right. So we have another guest.
Hello, Otto.
Hi.
We're talking about trying to make people better, and they actually give people poop pills.
Yeah.
Yuck. I know. I don't know if I could take one either, no matter how sick I was.
You know, in terms of
I
curing
think
people
when
of
it came down
depression,
to it, much better scenario than
What-
once you take it, you're cured like within a couple days.
Yeah.
what if you, to cure depression, you kind of take a look inside, like your daughter's head,
Mm-hmm.
her brain, very happy brain, looks very happy brain. And if you could replicate that and hook her up to someone who's very, very depressed, and it'll bang, it'll turn them into a happy person. So what if the secret is maybe little girls' brains, the neurons in little girls' brains?
Oh, I better hide her then.
Let's not go sinister now. It's just the recording of the brain, not the actual brain itself. You don't have to can opener it. Take a can opener and open it up and give people brain pills or something. It's like showing someone a home movie. You put a thinking cap on, and it actually helps you out thinking-wise.
That's awesome. Yeah, there's all sorts of really bizarre stuff out there, but it's cool. It's interesting.
Well, look at the connection that exists usually between parents and their kids. Just like now. Maybe, you know, if you could have that same kind of an interpersonal connection where you can identify each other's moods and then create that same kind of connection between adults.
If you were able to do the emotional transference thing we were talking about earlier, would that cause individuals to fall for each other?
Oh, that's interesting. I don't know. Yeah, I say why not too.
Well, we were talking about that movie Her with Joaquin Phoenix, where he developed a relationship with an AI, the AI can interpret his neurons and either directly affect his neurons. I don't think that was the case in the movie, but could certainly communicate more effectively with him in a relationship, because it could directly record his neurons, what his neurons were doing. Neurons, AI being able to know the mood we're in. An AI dating service?
You know, all this stuff is so much information they're harvesting in every way. Yeah, all this is going to be out there, and they're already kind of doing it to a certain extent. They're going to integrate health data onto the phones more and more. I know Apple has their version, and everybody has their version of doing it, and it's weak at the moment, but it will continue to graduate to new levels.
This next story, and I'm not going to read the whole thing, but these are microscallops, and they're small enough they can swim inside your eyeballs. So now you're talking about technology. Like if you want to talk about delivering shit, prebiotics, or whatever you want to call it, you got these little swimmers to do it. You don't need capsules or anything. They got these little swimmers can go into your system and deliver the drug or whatever it is instantaneously. And maybe they be constructed to just dissolve.
Yeah, I think there will be our bloodstreams will be full of these things in the future, where they'll be monitoring our health, and we'll be able to interact with the medicine in our bloodstreams that make us better.
And it's being able to quickly identify the effect the medication is having on you. Now, if you have to wait until you're in a seizure, that's not so good. But if there's instruments connected to you that can tell very quickly what effect the medication is having on your body, and that will happen at some point, there goes side effects.
Yeah. CRISPR-Cas9 future. Not just for us, but our bacteria, everything.
The stars, but I was okay. Dale, looking from stories number 6 down to 9.
Mm-hmm.
I'm hoping that you could cover them.
Sure.
You know the language better than I do.
Okay, so I'll read through these. Oxytocin levels in blood, cerebrospinal fluid are linked.
You can pick any one you want.
I'll start with the first one. That sounds
Okay.
interesting. So oxytocin is kind of the pleasure molecule. And they said that the levels are linked to your cerebrospinal fluid, which is kind of cool. For years, scientists have debated how best to assess brain levels of oxytocin. You can't easily get in there to find out what's present. So a hormone implicated in social behaviors. Now researchers at Stanford University School of Medicine have found the first direct evidence in children that blood oxytocin measurements are tightly linked to levels of oxytocin in cerebrospinal fluid, which bathes the brain. Low oxytocin levels in blood and CSF are both correlated to high anxiety levels, the research also showed. So, yeah, so those low levels are not good as far as anxiety. The findings will be published online November 4th in Molecular Psychiatry. So many psychiatric disorders involve disruptions to social functioning. said the study senior author Karen Parker, PhD, assistant professor of psychiatry and behavioral sciences. This study helps scientifically validate the use of measuring oxytocin in the blood and suggests that oxytocin may be a biomarker to anxiety. It raises the possibility that oxytocin can be considered a therapeutic target across a variety of psychiatric disorders. That's for sure. So an invasive procedure. Collecting CSF requires an invasive lumbar puncture procedure. Ouch. That's where the needle is inserted in the space around the spine.
That does not sound like fun.
No, that would be horrible. To avoid this, scientists measure oxytocin in the blood, but they have been unsure how well these measurements reflected the hormones levels in the central nervous system. So the new study shows that although oxytocin levels are consistently lower in blood than in CSF, the levels of the hormone in the two are linked. Isn't that interesting? To conduct the research, Parker's team sought volunteers from among a group of people who needed lumbar punctures for medical reasons. The study included 27 subject ages 4 to 64. With the volunteers' consent, the researchers tested oxytocin levels in CSF obtained during the lumbar puncture. They collected blood samples at the same time that the CSF was obtained. Parents of 10 children enrolled in the study and answered a questionnaire about the children's anxiety levels. The fact that we measured blood and CSF at the same time shows this is the first time there's a tight relationship between oxytocin levels in those two compartments, blood and CSF, and anxiety. So said the study's lead author, Dean Carson, who's a doctoral scholar in psychiatry and behavior sciences. Oxytocin levels were lower in the blood than in the CSF, but the concentrations in the two compartments followed similar patterns. People with relatively low blood oxytocin also had low CSF oxytocin, while those in high levels of the hormone in one compartment also had high levels in the other. Low oxytocin levels were linked to higher anxiety scores. And on autistic children, varying oxytocin levels. I was amazed by how beautiful the data looked, Parker said, noting that the correlations between oxytocin and anxiety were surprisingly strong for a small study, providing interesting fodder for future research. I think it opened a lot more doors. For instance, Carson and Parker want to know whether oxytocin could treat anxiety in some kids with autism. Social anxiety affects 80 to 90% of children with autism, Parker noted. Recently published research by her team showed that oxytocin levels vary in children with autism, which hints that different children will derive different levels of benefit from oxytocin therapy. Our belief is that there are oxytocin responders and non-responders, Carson said, adding that team is not testing hypothesis. Research provides hope for a future in which there will be less guesswork in treating psychiatric disorders. Being able to have objective measurements of psychiatric illness really will enhance early diagnosis and measures of treatment outcomes, Carson said. The team also wants to see if links between oxytocin and anxiety are limited to social anxieties, or if they can apply to non-social fears such as phobia of spiders. This research is a first look into an interesting set of questions, Carson said. They need to be further investigated in a more tightly controlled population. That sounds like some good science. It's a small study, they admit that. There's interesting, really, really interesting correlations between anxiety and low oxytocin levels in blood, and they've been able to compare it precisely with people that had CSF drawdowns curves. So good study, very interesting, and that could be more helpful than for certain people where SRRIs don't work. The reuptake inhibitors that are commonly sent out with people, they don't work for a lot of people, and a lot of people they do. So it's really interesting.
And it's certainly much better to get your test and your samples from blood as opposed to a lumbar puncture.
Oh, yeah. Well, you can just go to any clinic or any doctor, whoever can do your blood, and a lab can tell you and again grade you, based on your oxytocin level.
You can build baselines more quickly with an individual, their oxytocin levels.
There's so much data coming out, and the understanding the data is getting better. Interpretation, I really hope AIs move along quicker, because we're just not able to interpret the wealth of data that's out there.
That's kind of what that study is, really. You're talking about they're building that baseline. They're finding out more information, and they have a better test for getting that information.
Yeah, for sure. Absolutely. Okay, let's look at the next one. Scientists create Parkinson's disease in a dish. Never heard of that. Immunohistochemistry for alpha-synuclein showing positive staining of intraneural Lewy body in the substantia nigra in Parkinson's disease. There's some pictures on top there. So they've used some sort of staining to declare something. So a team of scientists created a human stem cell disease model. Interesting. Of Parkinson's disease in a dish. And guess what? I bet you I know how they did that. And I bet you it's CRISPR-Cas9. So studying a pair of identical twins, one affected and one unaffected with Parkinson's disease, another unrelated Parkinson's patient, and 4 healthy control subjects, the scientists were able to observe key features of the disease in the laboratory, specifically differences in the patient's neurons' ability to produce dopamine, the molecule that is deficient in Parkinson's disease. So attributed to a combination of genetic and non-genetic factors, Parkinson's disease has no completely effective therapy or cure. Parkinson's disease is moderately heritable, but the mechanisms of this inheritance are not well understood. While genetic forms of the disease exist, sporadic forms are far more common. The unique scenario of identical twins, one with disease and one without, allowed our scientists an unprecedented look into the mechanisms of Parkinson's disease. Advanced stem cell research techniques allow us to push the boundaries of science and see what exactly goes wrong at the cellular level step by step during the disease process. DNA mutations resulting in the production of a specific enzyme called glucocerebrosidase, GBA, have been linked to a 5-fold greater risk of developing Parkinson's disease. However, only 30% of individuals with the mutation have been shown to develop Parkinson's by the age of 80. This discordance suggests that multiple factors contribute to the development of Parkinson's disease, including both genetic and non-genetic factors. To date, there has been no appropriate model to identify and test multiple triggers leading to the onset of the disease. In this study, published in Cell Reports, a set of identical twins, both with GBA mutation, provided a unique opportunity to evaluate and dissect the genetic and non-genetic contributions to the development of Parkinson's disease in one twin and a lack of disease in the other. The scientists made induced pluripotent stem cells from skin samples from both twins to generate a cellular model of Parkinson's in a dish. So recapitulating key features of the disease, specifically the accumulation of alpha-synuclein and dopamine deficiency. So again, they're using engineered cells, right? So they're taking the skin cells, bringing them back to a pluripotent state. They're inducing pluripotence, and they're using that for science. And they're probably using, I bet you, something very similar to CRISPR-Cas9 techniques to do nucleotide knockouts and those sorts of things to simulate Parkinson's. So upon analyzing the cell models, the scientists found that the dopamine-producing neurons from both twins had reduced GBA enzymatic activity, elevated alpha-synuclein protein levels, and reduced capacity to synthesize and release dopamine. In comparison to his unaffected brother, the neurons generated from the affected twin produced less dopamine and higher levels of an enzyme called monoamine oxidase B, MAO-B, and poor ability to connect with each other. So treating the neurons with molecules that lowered the activity of MAO-B, together with overexpressed GBA, normalized alpha-synuclein levels in cell models. This suggests that a combination therapy for the affected twin may be possible by simultaneously targeting these two enzymes. And by the way, GBA, I just read something on another disease. Which one was it? And they talked about how GABA modulates incorrect neural activity. So all these different studies are kind of crossing over one another, and that's interesting. So the subject of Parkinson's disease, discordant twins, gave us an incredible opportunity to utilize stem cell models of disease in a dish to unlock some of the biological mechanisms of the disease. Working with these various different groups and scientists added to the depth and value of the research. We hope our findings will be applicable to other Parkinson's disease patients and other neurodegenerative disorders. In this particular scenario, genetic and stem cell analysis identified an avenue for a potentially useful combination therapy for the twin affected by Parkinson's disease and is applicable more broadly to the Parkinson's patient. While this case study is unique, type of research and cellular analysis will further include cases of genetic and sporadic Parkinson's disease and other related neurological disorders. Well, that's brilliant. You use twins, one with Parkinson's, one without. You induce pluripotence within their skin cells and watch them as they grow in a petri dish. Brilliant. Good science. I think they learned a lot from that one.
Yeah.
Not a great disease.
No. I have a couple of older friends, and my perception is it's something that tends to affect, or you see it as people get older than in younger people, but it can affect both.
Yeah, that was a good study.
Twins, when you can study twins, identical twins possibly, you're going to more likely be able to identify those epigenetic changes because the genes are going to be almost exactly the same. How the genes, the blueprint in the DNA is going to be almost exactly the same.
It's all about that damn mutation rate. As that mutation rate, your body mutates more and more. All sorts of.
It's 11 o'clock.
All sorts of random things take place where you have Parkinson's-like symptoms. And
is that Siri telling you it's 11 o'clock? Because I think Siri changed its voice. I don't know.
That's my computer. It always. That's my cuckoo clock. It's keeping time for us. But if you don't mind, let's go into the next one.
Okay.
Universe faces a darker future. Is dark matter being swallowed up by dark energy? I didn't think they had a good handle on dark energy and dark matter yet.
I don't think anybody has a good handle on dark energy at this point.
Where's Patrick? I bet you Patrick knows more about this. Do we have a good handle on dark energy and matter?
Dark energy and dark matter aren't really a thing because nobody knows what the heck they are.
Okay, so it's sort of, pardon the pun, but it's a big black box. So.
It's a placeholder text.
Okay, mathematical placeholder?
Something like that, yeah. It's like, we don't know what this variable does, but we know this variable exists.
Okay, fair enough. I'll read through this. New research offers a novel insight into the nature of dark matter and dark energy and what the future of our universe might be. Researchers in Portsmouth and Rome have found hints that dark matter, the cosmic scaffolding on which our universe is built, is being slowly erased, swallowed up by dark energy.
Okay, I want to. That's the question. It says that dark energy is the cosmic scaffolding on which our universe is built.
That's a big statement, isn't it?
I don't know. I don't know, obviously, but I've never heard dark energy described in that way. I've heard space-time described in that way.
Yeah, space-time is the scaffolding, is what I tend to think of, like Einstein's scaffolding of matter. But yeah, that's very true. That makes me kind of suspicious and skeptical of this article.
That's what I was wondering. Patrick, have you ever heard it expressed as dark matter being the cosmic scaffolding on which our universe is built?
Kind of.
Hmm.
So, have you ever seen those galaxy maps? Not maps of like a single galaxy, but like the portion. Okay, they're pointing their telescope at a single spot in the galaxy, right? And the way the galaxies are aligned, they're in local groups and then clusters and superclusters and et cetera, et cetera. But it looks like you were looking into the brain, like a map of neurons, a web of sorts. And I guess they would be saying that the dark energy or dark matter is what they're talking about?
Dark matter.
It's the same thing. Dark matter, okay. What they could say is the dark matter is the dead spots, I guess, or it's the stuff that's actually connecting the galaxies together as a framework, is what they're saying, I guess. So.
I see. Okay, well, I'll continue reading through, but that was a good observation, Ed. That's interesting. So the finding appears in the journal Physical Review Letters published by the American Physical Society. In the journal, cosmologists at the universities of Portsmouth and Rome argue that the latest astronomical data favors a dark energy that grows as it interacts with dark matter, and this appears to be slowing the growth of structure in the cosmos. Professor David Wands, director of Portsmouth's Institute of Cosmology and Gravitation, is one on the research team. He said, this study is about the fundamental properties of space-time on a cosmic scale. This is about our universe and its fate. If the dark energy is growing and dark matter is evaporating, we will end up with a big, empty, boring universe with almost nothing in it. Dark matter provides a framework for structures to grow in the universe. The galaxies we see are built on that scaffolding, and what we are seeing here in these findings suggests that dark matter is evaporating. It's slowing that growth of the structure. Cosmology underwent a paradigm shift in 1998 when researchers announced that the rate at which the universe was expanding was accelerating. The idea of a constant dark energy through space-time, a cosmological constant, became the standard model of cosmology. But now, the Portsmouth and Rome researchers believe they found a better description, including energy transfer between dark energy and dark matter. So yeah, that changes the paradigm significantly, but anytime you change anything that major, they're going to need to back this with a whole lot of research. So it's interesting at this point for sure, but I wouldn't change the, all the other research that's been gone into space-time. So research.
Before this is widely accepted.
What's that?
There will be a lot of pushback before this is widely accepted.
Yeah, it needs pushback, absolutely. Research students Valencia Savitelli and Najla Said from the University of Rome worked in Portsmouth with Dr. Marco Gruni and Professor Wands, and with Professor Alessandro Melchiori in Rome. They examined data from a number of astronomical surveys, including the Sloan Digital Sky Survey, and used the growth of structure revealed by these surveys to test different models of dark energy. Professor Wands said Valencia and Najla spent several months here over the summer looking at the consequences of the latest observations. Much more data is available now than it was in 1998, and it appears that the standard model is no longer sufficient to describe all of the data. We think we've found a better model of dark energy. Since the 1990s, astronomers have been convinced that something is causing the expansion of our universe to accelerate. The simplest explanation was that empty space of vacuum at an energy density that was a cosmological constant. However, there's growing evidence that this simple model cannot explain the full range of astronomical data researchers now have access to. In particular, the growth of cosmic structure, galaxies and clusters of galaxies seem to be slower than expected. Professor Dragan Kucherer of the University of Michigan has read the research and said the scientists need to take notice of the findings. He said the paper does look very interesting. Anytime there's a new development in the dark energy sector, we need to take notice since so little is understood about it. I would not say, however, that I'm surprised at the results, that they come out different than in the simplest model with no interactions. We've known for some months now that there's some problem in all data fitting perfectly to the standard simplest model. So I think these researchers they've found something, and they've made a hypothesis, and as Patrick said, it needs to be challenged. And hopefully they're challenging their own data, and it certainly sounds like that's a fair article, I think. What do you think, Ed?
Yeah, they talk about dark matter as evaporating, slowing the growth of the structure, slowing the growth of the universe. I guess the universe is expanding, okay? I think that is a fact. Is matter getting less? Is there less and less matter? And we're talking about this dark matter. We don't know what it is. We know it's there. We can observe that there's something there that we're calling dark matter. And I guess where I'm getting confused here, and I don't know you guys have the answer, is when they talk about energy absorbing, the dark energy absorbing the dark matter. Matter being converted to energy?
Well, they say that's happening, and I don't think they're anywhere even close to understanding how, but they're making a deduction probably based on observation.
Matter and energy.
Manifestations of the same thing.
Matter exists. Energy, matter is made up of energy. Is that a correct statement?
Yes.
Yeah.
Okay. No, they got me confused. That's all right.
Well, dark matter will be something that will have gravitational mass, right? Where energy will not.
Okay.
When something is at its energetic, and I'm not a cosmologist.
When we talk about the mass of something, aren't we talking about its energy? The amount of energy in it?
No.
Okay.
When you talk about an object's mass, you're talking about how much matter it makes up, or makes it up.
Oh, okay.
You talk about an object's energy, you're talking in like joules or newtons. And newtons are usually potential energy. Joules would be like, it's not kinetic, it's like, I guess as it's happening, it's joules.
And my understanding is it's just a different way to measure the same manifestation. So you can measure something by its mass or by its energy content, but you're really you're really measuring the same thing with just a different type of measurement. So you could, for instance, you could say 25 kilowatt hours is 90 megajoules. Same thing.
Has that relationship between energy and matter.
Yeah, there are two properties of the same thing, but yeah, it's a tough one. Because basically he came down to E equals mc squared, right? Which was energy is equal to your mass times the speed of light squared.
Right.
So that's the relationship.
Because that's how when you split apart an atom, you're releasing energy. And the energy you're releasing is when you're overcoming the weak interaction.
Oh, so you're talking about the nuclear potential energy.
Yeah, I guess that's a better way of putting it, obviously.
So, yeah, changing the mass energy equivalence indicates that there's large amounts of energy released in reactions, like the nuclear reactions. And basically the mass is removed from the system and it changes to a pure energetic state.
Okay, is this a statement that could make sense? If once we identify what dark matter is, then wouldn't that dark matter become potentially a source of enormous amount of energy for us?
Not necessarily. It's, well, potentially, but we don't actually know what it is, so probably not.
Very, very difficult to understand.
I can't remember enough about what I read to be even ask a good question.
So, no, that was an excellent question because you're talking about the mass-energy relationship, and there is a relationship, and it's E equals mc squared. So you're trying to interpret that in such a way where it can make sense, and I think the issue is we don't know enough about the three of us to understand nuclear physics. And I bet you just reading another article, going on to Wikipedia would spell it out quite clearly, because I think it's very clearly understood.
And it really comes down to we don't know what dark matter or dark energy is, so we really can't say a whole heck of a lot about either. It doesn't really seem to me that we're making a lot of progress in that regard, but it's such an unknown question. We don't, we don't even have the technology. If we don't have the technology that can observe it, then we can't very well make any really educated guesses about what it is and how it could be used. Big mystery.
It'd be interesting to see all the data they use, because they did mention a lot of newly available data that was never considered, prior to, space-time. So it would be interesting to.
And that even demonstrates how little we do know. We know something about this stuff over here. We don't know a thing about this other stuff over here. That shows you how little we know about how our universe works.
I'm looking at your last story here.
Okay. Please
and
do.
It's one that drives me crazy because I hate string theory.
I threw it in there because it said string theory.
It's actually, again, it's brilliant math and it's wonderful in its own way, but it can't ever be. It's frustrating because It can't ever be experimentally challenged, which kind of just makes me feel like, why are we doing it? And I'm sure there's very good reasons in a string
The
theory.
math people. It's interesting to the math people.
Yeah.
Uh,
Well, let's see what they said here. Maybe they found something here. USC scientists suggest a connection that could be a huge boost to string theory. Two USC researchers have proposed a link between string field theory and quantum mechanics that could open the door to using string field theory, or a broader version of it called M theory. So we get into brains and all that stuff and all that good stuff as the basis of all physics. This could solve the mystery of where quantum mechanics comes from. Boy, that's a huge statement. Rather than use quantum mechanics to validate string...
this is a PR guy writing this, don't forget.
Yeah. The researchers worked backwards and used string field theory to try to validate quantum mechanics. I actually know a string theory physicist who lives in our city, and he'd be really interesting to talk to, but the issue is usually he uses language in such a way that he very quickly moves far beyond the capacity to understand. So this could solve the mystery of where quantum mechanics comes from. Rather than use quantum mechanics to validate string field theory, the researchers worked backwards in string field theory to try to validate quantum mechanics. Oh, yikes. In their paper, which reformulated string field theory in clear language, Bars and Rickoff showed a set of fundamental quantum mechanical principles known as commutation rules may be derived from the geometry of strings joining and splitting. Our argument can be presented in bare bones in a hugely simplified mathematical structure. The essential ingredient is that the assumption that all matter is made up of strings and that the only possible interaction is joining, splitting, as specified in their version of string field theory. Physicists have long sought to unite quantum mechanics and general relativity and to explain why both work in their respective domains. First proposed in the 1970s, string theory resolved inconsistencies of quantum gravity and suggested that the fundamental unit of matter was a tiny string, not a point, and that the only possible interactions of matter are strings either joining or splitting. 4 decades later, physicists are still trying to hash out the rules of string theory, which seem to demand some interesting starting conditions to work, like extra dimensions, which may explain why quarks and leptons have electric charge, color, and flavor that distinguish them from one another. At present, no single set of rules can be used to explain all the physical interactions that occur in the observable universe. On large scales, scientists use classical Newtonian mechanics to describe how gravity holds the moon in its orbit, and why the force of a jet engine propels a jet forward. Newtonian mechanics is intuitive and can be often observed with the naked eye. On an incredibly tiny scale, such as 100 million times smaller than an atom, scientists use relativistic quantum field theory to describe the interactions of subatomic particles and the forces that hold quarks and leptons together inside protons, neutrons, and nuclei and atoms. Quantum mechanics is often counterintuitive, allowing the particles to be in 2 places at once, but is being repeatedly validated from the atom to the quarks. This has become an invaluable and accurate framework for understanding interactions of matter and energy at small distances. Quantum mechanics is extremely successful as a model for how things work at small scales, but it contains a big mystery, the unexplained foundational quantum commutation rules that predict uncertainty in the position and momentum of every point in the universe. The commutation rules don't have an explanation from a more fundamental perspective, but have been experimentally verified down to the smallest distances probed by the most powerful accelerators. Clearly the rules are correct, but they beg for an explanation of their origins in some physical phenomena that are even deeper, Barr said. The difficulty lies in the fact that there's no experimental data on the topic. Testing things on such a small scale is apparently beyond a scientist's technological ability. The research was funded by the Department of Energy. So yeah, can't be experimentally validated. So you know what? I think they're making a contribution in indirect ways, but science isn't good unless it describes nature and experiment.
Well, they're working on their theories. They're coming up with math. So it's entirely possible that someone else looking at that math will be able to come up with something that can be experimentally tested. And it may not be string theory, it might be something else. So that's the contribution they're making.
I bet what will come out of it in the end is indirect advancement. They'll help advance us in certain areas, and I think that's happened already. I can't cite any specifics, but I remember from listening to quantum physicists lecture that there's indirect advances they've made within the field of physics as a whole, but it's not about string theory. It's about the advancement of the mathematics and other indirect things. So.
Okay, would you say string theory? Now, string theory is backed by mathematical equations. And mathematical equations, the sums work or they don't work. But again, it can't be experimentally tested. Does that put it on the same footing or a similar footing as religion?
No.
Come on. I say God, you say string theory. What's the diff?
Well, in string theory, that's a great question. I think in string theory, they're taking known pieces of data and they're doing some interesting math with the known testable data that's out there. But they can only come up with a hypothesis of how things work. And because it can't be tested, it's a real problem. Religion is about feeling and having faith in something that you just want to believe is true. You want to believe that there is a God. You want to believe that certain things are the way they are, but there's no empirical evidence based around religion. They're just two different things. One is more the area around mythology, with really interesting, nice stories that humans are prone to believe in, and we're geared that way. It's the way our brains function. It's how we've evolved to believe in a creator. But there's so many things out there that we want to believe, and it never works that way. And you know, if you take gravity, if I take a stone, a large stone, and a flat piece of paper, and I tell somebody in a room that these objects fall at the same rate, everybody's going to say I'm lying. They won't. Objects don't fall at the same rate. But as soon as I crumple that paper to take away the air resistance, they'll fall at precisely the same rate. If you evacuate the air resistance, but it's not intuitive, and our brains don't work like that. We have to work very hard to do science, to reverse engineer and mathematically describe nature and then test it over and over, because we do believe in and jump to conclusions on different things, and only tested empirical evidence can clear that. So I think it has nothing to do with God.
I don't know. Since we don't have an empirical test to test string theory, what makes string theory more probable to be true than saying a God exists?
Well,
which of those? What makes one more probable to be true than the other?
Okay, so I talked about the string theory side, which is based on real data, but they're mathematically describing things based on the real empirical data. In religion, you're looking at Stone Age peasants that wrote a book that didn't understand that how the sun, the relationship between the sun and the earth, they didn't understand whether the earth was flat, and we're going to base our society on a book that was written by these uneducated people that created these myths.
Isn't the starting point that these individuals believe or say that they received this information with what they call a God, that's something from outside or outside the universe, this entity they think exists, but the fact that it interacted with them and caused them to write down this information in a holy book?
Well, you
so
can't.
It's that the key, when thinking about religion, the key is that interaction that's occurring, or you think that is occurring, between you and this entity that's outside our known existence. And string theory, strings, I don't know if you know inside or outside, but in terms of what we know about them, what we can prove about them, that's also outside our what we know, our base of knowledge.
They're both untestable hypotheses. They're both untestable.
That's my starting point. Okay.
But one is based on empirical data, is the starting point, and the other one is based on medieval peasants that wrote books.
That part I don't necessarily agree with.
No?
I think, for instance, when I'm talking to Christians, that's just a particular group of people that I interact with and I talk to them. The foundation of their belief is not words in the Bible. The foundation of their belief is what they call their personal relationship with their God. That is an interaction, a feeling that they get, that they say causes them to behave in a particular way or motivates them to behave in a particular way. Not the Bible. The Bible is kind of like this little mechanism, if you want to. It's a tool. So you have to forget about the Bible, as far as I'm concerned.
So,
the Bible is an excuse for their own actions.
So you have.
I think you can throw away the Bible and you still have religion.
Yeah.
Yeah,
very few people who actually preach the Bible have actually ever read the Bible.
No, that's true. I have talked to Christians, and I had a Bible study in my blog, and what you're saying is exactly right. Where I, as an atheist, questioned them on something. Well, to me, it's the difference between the first book of Genesis and the second book of Genesis, and the difference in the timeline between the creation of humans and animals. And there's a conflict there, and they don't want to know that. They don't want to know that. And many of them have never even heard of the second book of Genesis. And these are people who read the Bible every day.
There's an awesome website that has a mind graph or a mind node graph of all of the different contradictions in the Bible, and it goes it's got all these arcs that go across, and you can just click on an arc and it'll say this verse and this verse contradict each other, etc. And it's there's thousands of them. So
see, my problem is people believing. I think it's a dangerous path, and I'm not talking about religion. I'm talking about anything that isn't based on some sort of empirical evidence or data. Takes us down a very dangerous path, because you can say, well, I believe in the spaghetti monster, and the spaghetti monster, I have a personal relationship with the spaghetti monster, and it's telling me that I shouldn't give these drugs, these cancer drugs, to my children, because it's the work of heathen spaghetti people. So, I mean, it gets really, and it gets on the outer fringes. I'm not saying religious people, they're not crazy. They're wonderful people. There's lots of wonderful people out there. But I just think that anything that's not based on empirical data, it doesn't even have to be religion, it could be anything, can lead us down to a very unsafe society. You know, if we based our engineering on how we feel, you know, what would the structural stability of our buildings be? So I think the closer you get to empirically proven principles as far as the human mind can take us in that direction, I think that's a better place to be. And people have good intentions. Religious people have very, very good intentions. They're wonderful. They want to help other people and everything else. But there are fringes that base things on what their faith is telling them, and that's corrupted. Whereas science and data is just, the data is what the data is. And we get closer to interpreting it, and there can be, you know, I guess the other thing too is things beyond question. I love science because nothing is beyond question. Nothing is.
Religion's not above questioning. Look how many new groups and new religions have popped up over time. Religion evolves, just as technology evolves.
So why did they persecute Galileo?
That's one group of people persecuting someone, probably more overpowered, but that's one group of people persecuting another person who doesn't have the same belief system or challenges their belief system.
In the name of God, right?
Yes. I would say it's more in the name of power than in the name of God, but...
Or in Africa, they took condoms out of Africa, right? Do you remember that story?
Mm-hmm.
They pulled their funding because of faith reasons. They believed in abstinence. They were pushing abstinence. You know, there's lots of things that when you don't base it on empirical evidence, you can do a lot of damage. It's dangerous.
So can the technology that science produces can produce an awful lot of damage.
Yeah.
Science produces tools, but it's how you use those tools. But some of those tools, poisonous gas, biological weapons, aren't they more dangerous, possibly, than religion?
Okay. Yeah, I think so. I'll text her. Who uses those tools? What sort of groups would be inclined to use them?
Which tools are we talking about, religion or technology?
The awful technological tools.
Well, certainly the Nazis.
Yeah. So.
That's what. Go ahead.
I guess I'm saying it's all of humanity that we're all kind of the same, and but lots of times in religion, God is a convenient excuse that people do things in the name of God, and you don't hear of a lot of people blowing up other countries in the name of science. Science is about...
In the name of...
Science isn't a religion.
Oh, no, it's two different things. Yes. We're talking about value to society. Okay? The tool is created by science. It's up to the individual to decide how to use that tool. But the tool provides a potential. Couldn't biological weapons don't they have the potential of destroying, making the human race extinct? And in that regard, it's more dangerous than religion, which is more of morality-based. Certainly look at what's the evidence for valuing religion? And the evidence would be people who have used religion, motivated by religion, to make themselves better. They've cured addictions, etc. You had, for instance, the first group of people who opposed slavery in the United States were Christians. When we talk about Martin Luther King, he's a Christian. When we talk about the first people who marched against discrimination in the United States, we're talking about Christians. Think about people who have marched and taken opposition to war. In many cases, you're talking about Christians. People who their religious belief motivates them to believe that war is wrong.
Well, I think the moral high ground.
I don't want to make you hang around here. It's good, like maybe you're getting a little bit sleepy or ready to.
No, it's all good. The
Okay.
moral.
I also don't want to don't want your daughter to get mad at me. Heaven forbid, I do not want them to get mad at me.
No, not at all.
Okay.
So the moral high ground. I don't think the Bible is a good teacher of morals. And here's,
Okay.
so I'm an atheist.
Mm-hmm. So am I.
Okay, so where do we get our morals from? You seem to be a very, very good, very giving, open person. I've known you for a while now. I bet you'd say the same thing of me. Just the process of us doing this together is a wonderful thing. Where did we get those morals from? We didn't. The Bible's not telling us to do it. We're atheists. So, someone that believes in the Bible is more moral than us?
I would say could be just as moral or immoral. Could be either.
See, taking quotes from the Bible, there's things like ritual human sacrifice in the Bible. There's slavery in the Bible. There's all
But
sorts
I would say religion is evolving. Everything evolves. And religion is evolving.
They're
It
rewriting.
is entirely possible. I don't know what the odds are, but it's entirely possible that religion will evolve. People who think maybe like Buddhists, there's people call themselves Unitarians. You have the deist, and they will evolve religion, which helps create a society where people use technology better. And part of the reason they use that technology better is the morals they've learned from this evolved religion. Not the religion created 2,000 years ago, but the religion that is being created now.
See, and what you're basically saying is they're rewriting what they don't like.
Like? I don't know that that's the right word.
Well, either the book is true or
It
it's
isn't
not.
like. It's what is motivating you. It isn't a like or a dislike. It's the fact that you feel there's this entity, there's something you're interacting with that is moving you in a particular direction. It's not like you. In fact, many Christians, they've said they don't like the direction. They resist it. There's a lot of resistance among religious groups. They resist it. Muslims. For Muslims, when you talk about the word jihad, they've said that, or have read, the greatest jihad is against yourself. You're pushing against. You don't want to believe.
Yeah, and you know what? I don't worry about the midstream religious believers, whether it's Muslims or Christians or whatever. They're not the issue. The issue is for somebody on the fringe. It gives them that extra reason to do something in the name of God. And it opens up the ability to exploit a group of people into doing things they normally would not do. And you can desensitize people into doing terrible things in the name of God. Is that the average person that's doing their church at their local corner neighborhood church? No. They're trying their best to help, but I think what will happen is generations will go by and there will be less of a need for a God. I think that will. I think within 2 generations, religion will become rare. I think that's what will happen.
I actually agree with you on that. I would say it'll tend to become irrelevant. But I also have to accept, for instance, when you say science, okay, science helps me build this gun. And I can point this gun at you and get you to do what I want you to do. So the idea, you can get trapped into thinking that science alone, technology alone, is the answer. And it isn't. Any more than you can get trapped into thinking, well, God, I found this God, and whatever he tells me to do, it can't be wrong. I think there's an almost equal amount of danger in relying solely on technology as being the answer to producing a better society. And now morality is a hard thing to even identify, even say what it is. But if we had, for instance, I would rather live with a Christian minister with a Bible than an atheist with a drone who can kill me. The guy with the Bible, the guy talking about a religion, he's not going to, he'd have to go get the technology that science created in order to harm me.
But people are people, whether they're religious or non-religious. They'll all use technical tools. They're not really. I don't think there's a religion versus science. They're just 2 completely different things. And I think what science will do for us in the end, it will. The world is a much safer place because of science. The world is a much more educated place. We're now living in times with the least amount of conflict, and it's following a trend that's just getting better and better and better all the time, and it's because of science. And I don't think religion has any sort of bearing on that. There are no religious breakthroughs that are helping make discoveries. It doesn't make any sense. That's not what it is. It's a faith in a supernatural being. Where science is, there's no faith.
Okay, but when we're talking about the value, the potential of technology versus the value, the potential of religious belief in an entity that dictates and controls, well, I don't know about control, but the universe. And I think we'll take for AI, right? Artificial intelligence. Which is more dangerous? Which is potentially more dangerous? The belief in God or artificial intelligence?
I think ultimately, going down the road, artificial intelligence, if we do it wrong, and there's a good possibility that, it could be exponentially more dangerous than religion.
I
Yeah.
think we'll never get to there.
Can't hear you, Patrick.
I don't think we'll ever get to that point.
Yeah, Patrick might be right.
AI is, we talked about that last week, and that's really the big question in
Yeah.
terms of what's going to make our world better, what's going to help us make our world better. When we create that artificial intelligence and we become to rely more and more on that artificial intelligence, that's going to be a huge question.
Yeah. So yeah, I think the AI thing, hopefully it will roll out in a structured way that can be controlled. And I do worry about that. And I think it's coming, different types of AIs are coming quicker than anybody realizes. Because they're already in the systems, they're in the financial systems. They're weak AI, but they're AI nonetheless. And even weak AI, if you begin to trust it in order to make critical decisions, that can be a very dangerous thing. So it's going to be an interesting world. But yeah, the whole, there's lots of stuff with debates with science and religion. They kind of drive me crazy because they're not.
Are we getting a good handle on knowing enough about artificial intelligence to be able to control it when we need to? Are we perhaps, this is a case where could it be technology moving faster than our ability to understand it, understand how it could be used?
I think we're at the point where there's a lot of smart people, and I've seen some lectures surrounding sort of the ethics of what we're going to do with AIs. I think it's about setting protocols in place. And protocols are difficult on a worldwide scale, but hopefully it'll roll out something, like a successful, something successful like the open source movement, where everybody follows the rules, and there's such a wealth of people building software. Like Wikipedia is a great model of that. Whoever thought that it would be so tightly controlled by the masses, people in their homes doing things for free, to tightly control the content of a massive online encyclopedia that has seen no equivalent ever. Perhaps AI will be the same thing, where there will be such a wealth of people invested in that technology, like a Wikipedia, where anybody that attempts to pervert the code and not follow safe protocols, the masses will take care of them by ensuring that that doesn't happen, like the Wikipedia model. Maybe that will be it.
That is the question. We talk about the protocols. Are we putting these protocols in place that limit or to any degree control the developments that are happening in AI? Are there currently any protocols in place? Is there any kind of an agency or something that can say, okay, this artificial intelligent machine you're creating, that's not following, that has potentially too much danger, and we have to restrict what you're doing? Any kind of mechanism like that exists now?
Not that I know of. There was, I saw,
There isn't really the need for it right now.
what's that?
There isn't really the need for it right now. There's nothing that advanced.
Yeah, I agree. And there was there's a sci-fi writer who made a list of really intelligent protocols. And was it Isaac Asimov? And there's actually, it's very seriously being talked about by AI developers that a similar protocol for AIs to follow might be integrated into their.
Some are saying that you should never teach a robot those 3 laws because that just gives them the definition of what it is in the first place.
So it was the 3 AI laws. I'm just going to put this into Google.
A robot shall never harm a human being. A robot shall never harm itself unless it may harm another being. And I forget the third one.
Yeah, I just brought it up here. It's from Isaac Asimov. A robot may not injure a human being or, through inaction, allow a human being to come to harm. A robot must obey the orders given to it by human beings, except where such orders would conflict with the first law. And the third one is that a robot must protect its own existence, as long as such protection does not conflict with the first or second law.
That sounds good. Sounds good.
Yeah, it's interesting. And it's interesting that they're using a book written by Isaac Asimov. I've actually heard them seriously talk about, implanting these laws in future AIs.
I would say all those protocols are going to go out the window once AIs can create themselves, build their own programs. I think at that point, the question is going to be, are we of value are we our value and not a danger to these AIs? I think that would be the thing. We would have to be able to demonstrate to the AI that we're not a danger to them, and in fact we can be of benefit to them. We've got to convince the AI, sell ourselves to the AI at that point. And I think we can do it.
Let me ask you a question. So, you understand when we were talking about directed evolution, what that means? That we're controlling the world. And at our core, are we not very computational, like based on our DNA and microbiome? It's all code. Maybe we will direct our code in such a way that, or maybe we are the AIs that become super intelligent by modifying our biology. Is that a possibility?
Well, yes, I like your analogy, software. We're talking about software and hardware. We're software. I think there's always going to be the point where one piece of software, this machine, whatever it is, being run by this particular piece of software, is going to have to, well, it's going to interact with other software, the other software that exists, the other beings, this other software. And if one software program sees itself as in conflict with another, or sees the other being a virus, then we're going to have a war. We're going to have a war between these 2 pieces of software. And the only way to prevent that war between these 2 pieces of software is that they either become mutually dependent upon one another, or that they only work together. Or when the conflict arises, they programmatically find a way to resolve and work together, as opposed to viewing each other as a virus or as a destructive, someone that's trying to destruct it. Just like the viruses in our system, just like the bacteria in our system, same thing. It's got to be a symbiotic relationship that it's a benefit for both. Not a benefit for both, we got a problem. And that's going to be exactly true of whatever direction AI takes. It's always going to have to be up to our software to not interact with the AI software in a negative way, in a way that is perceived to be destructive.
Well, maybe it's programmed into the AIs that it's like the Soviet Union and the United States in the 70s and 80s, mutual destruction. If anybody made the wrong move, it was mutual destruction. And maybe that's what happens with the AIs. It's built into their software and hardware that if they contradict each other in a significant way, then it's mutual destruction.
That could be true, but then you always have, okay, we're going to be nice and friendly, but somewhere out back over in another part of your little software program, you're trying to figure out how to become a superior program to this other one.
Agreed.
Never-ending race. That's kind of, you know, a big circle anyway.
Totally agree.
But oh well.
Always makes for interesting conversation.
I'll tell you what, though, these are the kind of discussions that our leaders need to be talking about, that more people in society need to be talking about. I think they got blinders on. They don't even know what's happening.
No, they don't. They're being herded like sheep with their smartphones and being funneled into certain areas as a market commodity.
That's where I first put in that story when I wanted to get into the waste of things. Look at resources, waste. I mean, we talk about, okay, we need to find energy. Well, we already got enough energy. Let's find out how to use it better. You don't even necessarily have to spend buckets of money on improving the technology we already have. You can accomplish the exact same thing at much less cost by using what we have better.
Yeah, no, exactly.
And I don't see where our leaders get that.
I don't, and you know what? I think even the leadership regimes are going to change. Countries will dissolve. I think we're headed towards globalism with local focus. We're already doing that now, anyways. So, and you know what? The improvements will come from the grassroots.
Yes.
As they are now.
International trade in the internet.
Yeah.
It's 12 o'clock.
Okay, Guy. Oh, let's see. I guess we got to end this. We've just the AI, and and Ruma has just commanded us that it's now 12 o'clock.
What time is it there? Is it 1?
1 a.m.
Okay. So we used to be 2 hours apart. Now we're 1.
Yes, yes.
So if you put the
I
Thursday
can't
night.
handle this. I can't handle this time change business.
So if you put the if you wanted to, like if you put the Thursday night back an hour because it's better for other people, that's still the same for me. Because Saskatchewan doesn't change.
Let me think about this.
We didn't change time here. So for you, you scheduled it, right? For the same
Yeah, but 9 o'clock for me is going to be 7 o'clock for you.
Well, that's changed now because we're only
No,
1
it
hour
isn't.
apart.
I'm sorry, isn't it? Aren't you? Are you only an hour behind me?
We don't change ever. So for half the year, we're 2 hours behind you, and for the other half of the year, we're 1 hour behind you.
Okay, all right. Now I got you. Slowly getting there.
Yeah, it's weird.
Oh, okay, that's interesting.
Our province doesn't change time.
I
So
did
when
not
you
realize that. Well,
Yeah.
Thank you for pointing that out. That's one of the things in putting this together is the challenge of people having different time zones.
Yeah. Yeah, for sure. So, yeah, if you scheduled it an hour earlier, for me, it's still the same time. Because tonight, that's what I was kind of wondering why you weren't turning things on because of the time change. Because it was an hour later for me, which
Okay,
is
so let's-
fine. So you could make it an hour earlier now, and then that would be the same time for me.
so I can move it back to 9:30.
Yeah, which is 8:30 for me.
Okay. Man, we got to get together on this time business because I have that same problem with when I try to set up a European time friendly hangout, trying to figure out what time, Brian conjured in Ireland, what time zone is he in? And Yanni
Yeah.
out in Finland. It's just, I've really screwed up a couple of times.
I always ask people what city they live in, and then I put time in Toronto, and then I just compare it to mine. That's the only way I know how to do it accurately.
Yeah, I've got that world clock app.
Oh, okay. There you go.
Okay, because in terms of the only reason I pushed back the time is because I didn't want to, interrupt your lunch and dinner, and I wanted to make it into a time period that's better for you because we have some great discussions.
Yeah. No, you could push it back an hour,
Okay.
and that's still the same time for me by pushing it back an hour.
Okay.
And it doesn't matter if I have my doing on some food a little bit. That's all good. I'll just get off camera range.
Okay. All right. That is good. Anything else? I think of education.
What's
The
that?
education your daughter is getting, as opposed to the kind of education I got, or possibly you got as a child. I don't know. But I graduated from high school in 1961,
Yeah.
and it was really all rote training. Period. There were a lot of people who went on to very creative jobs, starting with that rote training, going into the internet, etc., going into the sciences, even though the education they got was rote training. But I'm sure there's also a lot of creative people who, because of that rote training, never didn't move beyond, didn't reach their potential.
I think education is all about should be lifelong, and there has to be better ways to keep people interested. You have to make it a game. You have to do things that follow our neurology that will keep us interested and engaged in it. And I think that's difficult to do in the conventional system. And I don't know, and again, I don't know of a better way to do it to educate the masses. So yeah, I don't know.
Emphasizing the creative side has got to be the way to the future. Because anything in rote, anything involving rote, the machine's going to do that. Any kind of jobs that involve, just building something, machines are going to take care of that. So we humans, we got to focus on the creativity side, and in schools, really focus in on children displaying creativity and encouraging that.
Yeah, I think that's where we'll be in a generation. Creativity will be very, very important, and the rest of it will be handled by our technology.
I know I've talked about that with Patrick in the past. That test needs to be build something. Don't parrot back to me, this is the instructions A, B, C, D. I want to know you understand it, so build something.
Yeah. Yeah, precisely. That's a good way of thinking about it.
But even in math, you could say, okay, for your test, you've got to create a mathematical formula. create your own mathematical formula.
Yeah, an algorithm.
Yes.
Develop an algorithm, and algorithms are simple, right? They don't have to be that complicated, and you can use them to interpret data. And that's essentially what synthetic biology is.
You know what you can do? Take that motor that Patrick has been working on, and you say, okay, here's this object. How are you going to fix it? Even if you don't have the materials, show me how you're going to fix it. And if we here are the materials, and then go ahead and fix it.
Yeah. Yeah, it should be more practical. Applied science.
Mm-hmm. Okay. Anything fascinating or interesting more that you want to talk about? Something we haven't talked about yet, or something new. Patrick said something. I couldn't quite hear him.
This whole time you guys have been talking, I've been tearing down a copier and I've been harvesting all of the good components out of it.
Awesome. I'm just waiting eagerly for the E-Wave announcements that are going to come out. Really interested in that. Is there anything to it?
That would be that quantum leap. All right, I'm impressed.
What kind of chipsets are on there?
Sharp. Winbond. MX. Toshiba.
Oh?
Quite a bit. This is actually a Xerox printer, I think. Yeah, it's Xerox. It's got a hodgepodge of stuff on it.
Huh.
Quite a few stepper motors. We were hoping to hook this up and use it, but it's got a serial port on it only. So we don't have any adapters.
Oh, yeah.
So it's pretty much useless. So we're taking it apart for spares. Scott wants all of the the metal plating in it so he can do some etching. Make like nameplates and that kind of stuff.
If you take the, you know the piece that does the scanning, the little light that does the scanning back and forth?
Yeah, I haven't gotten to that part yet, but
If you take it out and apply a DC voltage to the control circuit, it makes a really nice looking lightsaber.
oh yeah. Right now, I'm mostly interested in the stepper motors and the precision rods. Because with enough steppers and precision rods, you can make your own additive manufacturing fraction.
Cool. I see the most important piece of equipment on the video, the fridge.
Yeah.
What do you have in the fridge?
Oh, the fridge?
Yeah.
It's mostly beer. There's pizza in there right now, but it's mostly beer.
A critical staple in every important lab.
Yes, yes. Very much so.
That's awesome. So yeah, Ed, if that time works better, if you push it back, I'll still be on my same time. Because right now, today was an hour later for me.
And it really helps me when someone else can cover the stories as opposed to me doing all the time. Me just talking and reading a science article in itself, not going to be all that interesting. So I like it. The real key has been the discussions we're getting involved in. That's what makes it interesting. That's what has made it interesting.
Yeah. Well, cool. I think I'm going to turn in.
All right.
tonight, but that was how long did we go?
Let's see. It's 1:11 right now. We started at 10:30 my time. Maybe we started at 11.
Okay.
So that's 2 hours. Well, probably 2.5 hours.
Oh, that's pretty good.
So, oh yeah, very definitely. And the main thing is, it was interesting.
Yeah.
It's not me just repeating a story, and that's it. That's nice. I deliver stories with my little magazine, Science Island. And so for me to do it here, I'm repeating some of the same stories even. So
That's
the key here is interesting discussions, such as we've had the last 2 weeks. And hopefully I will have Saturday.
Well, I'll try to listen into part of that. I don't think I can go, but I will listen in if I can.
With like with Ulysses and Pamela, we're more likely to get into politics.
Oh yeah, that's
Something
all right.
we don't do much of here.
Well, I
That's
don't
the thing.
mind.
That's you get different personalities. You've got one personality. I've got one, and then you have Ulysses, which has a different set of interests.
Yeah.
He's lived in an area where most of the people he interacts with have a religious background or whatever, so he has difficulty getting involved in discussions with people who he gets to interact on a daily basis. So here, he gets to interact with people who think more like he does.
Yeah. Yeah. Absolutely.
And he's big on the ecology and the environment and the politics, which is always fun. So Saturday is going to be a nice, fun hangout.
Awesome. Well, if I can pop in and out, maybe I'll just pop in and I'll provoke him and then I'll run.
I hate to say it, but sometimes that's my job. I'm the provoker. Like I was a little bit tonight. I just love taking the contrarian position.
No, that's awesome. That's what makes the discussions good. So keep that going. Go harder. Nothing's beyond question.
That is the other thing. My real problem is memory. When I read stuff and I just can't remember what the heck it is. I read from one week to the next. And so I ask questions and learn from you guys.
Well, I don't.
All right.
I see you as a very smart individual, but I don't see any memory.
There you go. There you go. The internet. For the internet.
That's right.
Okay, see you next week then.
Yeah, take care, you guys.
Okay, Patrick. See you next week or possibly Saturday.
All right, later.
Bye.